Hello. We are going to look at two more examples of shifting and translating, stretching and reflecting graphs. So these graphs are very general to work with. If you look at the two examples, we want to use the graphs below. So these will be our functions. We don't know what the function rule is, but they are given by these piecewise defined functions. So this is essentially the graph of f for this function. And we want to use this graph of f to plot the new graph g of x with all these shifts, reflections, and stretches and compressions. What we see here is that we have two sort of differences from this graph of f in the first one. So we have an x minus 1 inside change. So we should know by now that the inside change is going to move the graph left or right. Since we have a negative one and it's counterintuitive, we know that this is going to move the graph right. So we're going to move the graph right 1 unit. And our second change is an outside change of -2. And outside changes are very intuitive. They just move that y value up or down. So this one's going to move our function down 2 units. So we can do these together, or we can do these in succession. So I'm going to try to do these together by just taking each point that I see here, and these are just hooked together by line segments, and I'm going to do exactly what this says. I'm going to move it right 1 and then down 2. So if I move this point right 1 and down 2, I have a point here. I move this one right 1 and down 2, I have a point here. I move this point right 1 and down 2, I have a point here. I move this one right 1 and down 2, I have a point here. And I move this one right 1 and down 2, I have a point here. So my graph, when I'm done with it, should look a lot like what we call the parent graph, the graph that's on there. And I just connect these by linear segments. However, we see that that graph has been shifted. So our new graph of g of x will look like this. This is essentially the function f of x, which has been moved right 1 and down 2. Okay, so this second graph has more going on. We might have to do this one in steps, which is totally okay. We have a negative out in front, so we know that that negative is going to stretch or compress the function vertically. But here we just have a 1, so it's not going to stretch or compress it at all. It is a negative out in front of the function, though. We know that that's going to reflect it about the x-axis. So this negative is going to reflect f of x about the x-axis. We have an x plus 2 inside change. So again, our inside changes are counterintuitive. So we know that just like a -1 inside moved it right 1, this one's going to move it left 2 units. And then finally, my outside change, which is totally intuitive, moves everything up 1 unit. When we have a lot of changes like this, sometimes we need to use priority. So here are the priority of our transformations. The first thing we would do is if we have any, we're going to do the horizontal shifts. That's why I moved everything right 1 first in this one, although it wouldn't really matter in that one. The next thing we are going to do is we're going to do the horizontal and vertical stretch and compression. Neither one of these have that. Although this one has a negative, so that's what we're going to get to next. So if we do have any reflections, we're going to do those thirds. And finally, fourth would be vertical shifts. So in our second graph here, we have a horizontal shift we'll do first, we'll reflect, and then we'll do our vertical shift. So I have my handy 4-colored pen. Hopefully it works. So I'm going to start by doing this horizontal shift left 2 units. So I'm going to move this just left 2. Move this one left 2. Move this point left 2. This point left 2. And this point left 2. So this, not going to be the total graph, but just my first step here. So my red graph is going to be step 1. All right. Next, I'm going to do this reflection. So I'm going to make every positive x negative. I'll do that in this color. So, if I have a negative 0, that's going to be the same point. Here I have positive 2, so this one's going to go down to negative 2. I have a positive 2, this one's going to go to negative 2. I have a positive 4, this one's going to go to negative 4. That should be over here, actually. And luckily, this was a pencil one. And then finally, this one is just going to be negative 0, which is the same place. So I can connect those. And remember, I'm not done yet, but this is going to be my second step here. Freehand that. There we go. So this will be step 2. So we've done the horizontal shift, left 2. We've done the reflection over the x-axis. And finally, we're going to move everything up 1 unit. All right, so what color do we have for that? Let's try green for the total graph. So I'm moving everything up 1 unit, up 1 unit, up 1 unit. So we're using this second step here, up 1 unit, up 1 unit, and up 1 unit. So now, even though we don't have the function rule, if we have the graph, we know how to change things now. So this green graph will be g of x in this case. Notice again how it's very similar to the one that we started with, but it's just been moved around. Specifically, it's been moved left 2 units, reflected about the x-axis, and then up 1 unit. All right, I hope this has helped.